And we're live. Testing 1, 2, 3, 4. Are you awake? I am. Today is it's May 10, 2024, and this is RockSim Live. My name is Tim Van Milligan, and I am the host. I am here to talk about RockSim, RockSim Pro, or the Launch Visualizer. We have the chat going on, and I have a computer monitor where I'm watching the chats come in. If you have a RockSim question, go ahead and put it in the chat, because that is the agenda, to talk about what you want to learn about. So far we've got a bunch of people in the room. We have 3D printer guy. We have Rosa from Ottawa, David Hayes from Michigan, Carlos from Marietta, Georgia, and Mark Sell from Parker, Colorado. Just checked in. Well, thank you all for being here. So fire off those questions. I only got one that came in by email, and it was a really simple one. It'll take me like about that long to answer it. Let's go to the screen here. Nope, not that one. This one. Oh, look, my face isn't there. I don't have my camera turned on. Let me turn that on. Oops, that's not the right camera. There we go. That's better. There was a big face in there. That was my screen capture camera. We have a whole bunch of Bob here from Buckeye, Arizona. Well, thank you, Bob, for being here. RockSim is from Apogee Components, and our web address is apogeerockets.com. When you come to our homepage, you'll see this sliding banner bar, and one of them will be RockSim 11. The one that was previous was the Launch Visualizer. The Launch Visualizer is our cloud-based version to run simulations. It doesn't design rockets, but it allows you to do simulations, and it's cloud-based, so you can do it anywhere in the world that you have access to the internet and a computer at rocksim.com. And so if you have questions about that, we can talk about that too. Mark Sell says, Tim is frozen. I hope I'm not frozen. David Hayes says, not here. 3D printer guy says, loud and clear for me. Okay, so I guess I'm live. So we are live. So if something's going on, it's happening live. Where was I? Okay, so we're talking about RockSim. If you would like to have a free demo, you can go to the how-to and guides, click on that, then come down here to software, and you can have the free trial. It's a 30-day trial. If you want to purchase it after that, go ahead and purchase it here. There's also what is RockSim, so if you want to see some of the main features, you can click on that. There's frequently asked questions, system requirements like what operating system do you need, and then changes. What were the changes along the way since we first introduced RockSim in, it was about 1996? It's been a long time ago. Man, that's going to be 30 years in just a couple more years. Whoo! And it gets better and better. It's not the same program it was 30 years ago. It's a lot better now, and we're still working on it. I was talking with our programmers yesterday, and there's a couple of bugs that we have noted here, and he's figuring them out, and he's going to try to give me an update so I can start testing it. So those bugs are going to be fixed here soonish. And then we want to get RockSim Pro version 4 out because we've had RockSim 11 out now for a couple of months, but RockSim Pro version 4 has lagged because of the map issue. We're still working on the map issue, but we at least got a partial solution that's working. It's not optimal yet, but it is working, and I still love it. It's still a great program. Okay, also on our website, you'll find tutorials. There's other questions like loading motors into RockSim. Although with RockSim version 11, that's not so much of an issue anymore because we made it automatic engine updates. And just today, my RockSim, my version 11, went out to the internet and it said, hey, there's some new motors out there. Do you want to grab them? And I said, sure. I don't know what new motors they are, but there was a bunch. So it just automatically downloaded them. So my database is up to date as of today. So the RockSim live training is what we're doing right now. We're on episode 166, I believe. Let me see. So RockSim live training. If I click on that, it'll take me to the archives. Yeah, so episode 166, because episode 165 was a couple of weeks ago. No, last week, 7 days ago. And this is what we talked about. We talked about the measuring tool, and I figured out what the problem was there. My programmer told me what causes that problem. So if you have it, we can talk about that. We talked about drawing custom fins, the RB02 beeper. Separating an egg capsule was our main topic. That one took the longest time. And then we talked about using mass override. All right, still no questions over there in the chat. What's going on? I'm waiting. All right, so let me open up RockSim here and get to our first question. The first one was from David Hayes from Michigan. And what he sent me was a SVG file. And he says, I got this SVG, and it's this table, and he would like to learn how to export that. So this is the simulation summary screen. So if you're in RockSim and you need to open up a design, so let's open one up here and see what we got. Come on, open. We'll open up last week we used the egg tosser. Let's try something different, just to be different. How about the Katana Junior? We were making new Katana Junior kits. We've been out of stock on them for a couple of weeks, and they're building them right now. So hopefully by the end of the day, they'll be back up on the website. The Katana Junior is this rocket. It's a smaller version of our big Katana. The big Katana is 4 inches in diameter. This one is based on a BT-70, so it's about 2.2 inches in diameter. Let me show you a picture. Not that one. I don't want that one. I'm going to go back to this one. Katana Junior. And that's what it looks like. And okay, how do I close this? That was weird. Still loading the images. That's how big it is. And there's a comparison photo right here of the Katana Junior and the big Katana. So let me go back to RockSim. So we're looking at the Katana Junior. RockSim, where are you? There you are. And the flight simulations tab is right here. So when you go to run simulations, it puts the results in this summary screen called the flight simulations summary screen. So for example, let me run a quick simulation here. So this is how you run a simulation if you've never done it before. You click on this button right there. That starts the process. Then from here, you're going to go across these tabs. The first one is to choose an engine. So I'm going to choose I don't know, let's go with the F42, select a delay, let's go with an 8-second delay, engine overhang is 0.5 inches. See, that's the amount that the engine sticks out the back because it affects the center of gravity, so we need to know it. Flight events, this is a dual deployment rocket, so we're going to deploy the 12-inch diameter at Apogee and then the 24-inch diameter at an altitude, let's call it 200 feet. Simulation controls, just leave it blank. Starting state, okay, so this is going to be a 72-inch, now let's make a 60-inch launch rod, so 5 feet, pointed straight up, so that's our launch angle. If you want to adjust the launch angle, you can either grab this turn wheel, you can just do that, and so then you can, this gives you a big gross changes, but if you want to do fine changes, like 0.1 degree. This is our weather conditions. I'm going to leave it at 700 feet above sea level, and we got a wind of 8 miles an hour. And we're not going to use any competition settings, and we'll just click launch and do a flight profile. You can see it started to load the information there while it's running the simulation, and then it loaded it, but I asked it to do a flight simulation. Oops, there it is. I thought I lost the screen there. So there's the rocket sitting on the pad, and we launch it, and we can get a visualization of what the rocket is doing, and it's going pretty much straight up. This is smoke from the exhaust, and it's just kind of drifting with the wind, and now the rocket's coming down. And you can speed things up by grabbing the slider bar. And now see right here, it was about 200 feet up, I can tell. So something happened because we're coming down a straight path, and then all of a sudden it changed. So that was when the main parachute came out, and it landed 284 feet downrange. So our dual deployment worked pretty good on that. So let's go back to this screen. So this is the flight summary screen. So how do you get that chart that, what was his name? David Hayes. Sorry, David, forgot your name there for a second. So how do you get this chart? So that's really simple to do. What you do is you just come to the screen right here, and then just do a right click on it. Right click with your mouse on the right mouse button, and then, oops, I'm going to go right click, and oops, there it is, right down, export table. So I'm going to export it, and it should bring up a screen. It says, where do I want to export it? And it's, you see it's a CSV, which is comma separated something other. It's a, like a spreadsheet program. I'm going to throw it on the desktop and hit save, and then it saved it. And if I go to my desktop, viewfinder window, and on my desktop, right there, there's that table. If I open it up, you'll see it is a CSV file. There it is. And, we have the engines loaded. So there's my engines loaded, E16-4, E16-4. The last one was an F42-8. Maximum altitude. Then we have velocity at deployment, optimal delay, launch mass. So we need to make this table and slide it, because we're not seeing all the columns. Yep, and so all the columns that you're showing up here are what's being exported. So now you can change these columns, what you display, by doing, again, right click, but this time you got to do it on the header column. Do a right click up there, and then say organize columns. And here's all the other stuff that you could display in this chart. Like, I don't really need that column though. Liftoff speed, we can turn off comments, altitude at deployment, click OK. So you see now I have, my chart is different, and so if I were to export it now, all these new columns will show up. If you want to arrange the columns, just take the column header and then just slide it to where you want it in the list. And you can see I just moved that one over there. If I want to take the manufacturers and put it over here next to the rocket motors, it didn't get there quite yet. There it is. So that E16-4 was an Estes motor. The F52 was an Aerotech. So it's really easy to export out that chart. And then the recommended motor chart is very similar. In fact, it's identical. If I had a recommended motor chart here, I could just export that out. So I have this. A lot of people like to put these in a binder with their rocket, all their rocket information. So they, when they go out to the launch site, they know what motor, what delay to use, how high do they expect it to go. All very important stuff. So very good question, David. All right. Marcel says, I haven't upgraded to RockSim 11 yet, so I don't have any new questions. Okay, so last week we were trying to use this, the measure tool, and the measure tool allows you to measure 2 points. So you click on it, and then you can click another point, and it will give you the distance between those 2 points. And there are certain rockets that it doesn't work. And that's what we discovered last week. Although last week we didn't know what caused it, now we do know what causes it. And what causes it is each of these components has a serial number. And you don't see it. It's hidden. It's in the code. But if a body tube is not in the second position, so so the first position, its serial number would start with a 1. In the second position, its serial number starts with a 2. And if the software, it uses the body tube as the reference, because we know this diameter of this body tube, and we use that to make distance measurements. So, if I click here to here, I get 2.137 inches, and we know that that tube is actually, I'm not, I didn't click directly on the line, but that tube diameter is 2.210 inches right there. So that's what we're using to calculate distances, is that body tube diameter. So if the body tube doesn't have a serial number that starts with a 2, then this doesn't work. And so how does it not start with a number 2? And we figure that out as well. And what happens is you can copy and paste parts and move them around. So it's like this tube right here, this is not in the number 2 position, but I could copy that tube and then paste it to the nose cone. So the serial number stayed the same, but now it's in a new position. And that confuses RockSim, and that's why that measuring tool might not work. So the solution is, delete that tube and then add it fresh. So if this tube wasn't there, I would add a new tube just below it, just like, body tube, and then you just start adding it. So that's the workaround for right now, but in the future, we just want to fix the problem so that it doesn't care what serial number that part has in the database. It just should work. You shouldn't get that error. So that was from last week. That was, why doesn't the measuring tool work? Okay. Sturco3 is here. Yeah, thank you, Sturco3, for coming in. Hi Tim, can you make a transition from a BT60 to 80 and then see a design, and then can you print it out to use the guide to cut one out of cardstock or whatever material you suggest? So he wants to make a transition from a BT60 to a BT80. Okay, so let's start a new design. I'm going to go design new, and it's going to ask me, do I want to save the old one? I'm going to say no. So I'm going to start with a nose cone, and I want a BT60, which is a 41.6 nose cone, 41.6 millimeters. Where are you? I guess we'll choose an Estes. So where are they? PNC 18, 33, 40, BT20. What's going on? There's a BT60. All right, whoa, it's got a really wonky shoulder on it. Okay, so the outside diameter is 1.64. Let's correct this shoulder. So this like is too skinny, or yeah, so we want to make it bigger. So I'm going to choose a compatible body tube. I know it's going to be a 41.6, and see, then it just made it the correct size. Now the length of it, you can change that if you so choose. Make it 1.25, so now it's a little shorter. This is a long nose cone. This is 9.75 inches long, so this is a big one. We can shorten that up by going to the General tab. And here's the length, and I can just grab the slider and just make it shorter. All right, we'll just leave it like that. We're doing transitions. It's okay, so now we're going to add a body tube, and notice this is in position 2. So our measuring tool should work. And it does, just like that. All right, so there's a body tube, and now we need to make a transition. So I'm going to add the transition here, and I'm going to exit out of the database because we're going to make it from scratch. And to do that, we need to set the front diameter and the rear diameter. And what we're going to do is we're going to go to the shoulder, and we're going to set it there. So the front shoulder is this tube right here. That's the BT60, which is 41.6. So we're going to choose a compatible body tube. And again, I'm going to choose that one. And you can see it put the shoulder in there. And then the rear shoulder is going to be a BT80. So I'm going to choose a compatible body tube. And BT80 is a 66 millimeter. So I'm going to choose that one, and you can see it put its shoulder right there, and then the transition, we have to go back to the General tab, click on that, and now we need to change the length. So here's the length, and if I just change the slider, you can see my transition is growing. All right, so we need to make it out of material. Let's call it paper. Let's make it, well, hollow, and give it a thickness 0.04, oh, that'd be too thick. 0.15, let's call it. I'm just guessing in my head. Okay, so we have a transition. So let's click OK there and take a look at it. Let's look at it in 3D. So there's our transition. Okay, so now he wants to print this out so you can actually make a transition out of paper. All right, so what I'm going to show you, it's at this point, it's not going to work. And I'll show you why. Okay, so first let's go to print, and we're going to print, I'm not going to print out any simulation information. I want to print out rocket information. I'm not doing any placement wraps. So those are wraps that you go around the rocket for like putting fins on. We're not going to do that. I don't want the side view. I want templates for a transition. So I'm going to click on that. I'm going to click OK. And the print menu should come up. And I'm going to print it to a PDF. So I'm on a Mac. I'm going to say open this in preview. And look what it gave me. It didn't give me what I wanted, right? And that's not even what I wanted. That's not even what I was hoping for. Let's try that again. I want templates. I don't want drawings. Let's see what happens when I do a body tube. It kind of like it was giving me a parts list. Why is the parts list showing? Transition. Parts list would be, oh, here's parts list. Okay. I just want templates. All right, see what happens this time. Okay. Print to open in preview. And okay. So here is my transition, which you can't see. Is there anything on this transition? No. So why didn't it show up there? Let's print a nose cone. See if I'm doing something wrong. This is how you troubleshoot things. Let me see. Template outline color is black, so I didn't print it in white. Let's make it a different color, like blue, just in case. Template fill color, template hole color. Defaults, template registry. Okay, and PDF. Oops. Click too fast. I clicked too fast. I want to open it in preview. Okay, so there's my nose cone. Why didn't my transition should have looked similar to this. But that's not what we want for this transition. We want a wrap that we can cut out. And to do that, you have to do some special things. There's 3 things that you got to do. So we got to go back to the transition. Let's export out a template here. This is going to be different. So I'm going to say export template. And then we're going to save it as an SVG. SVG stands for Scalable Vector Graphics. And I'm going to need to open that in a vector program, and I need Adobe Illustrator. We're going to call it transition. Let's put it on the desktop. And hit save. And I just exported it out, and that tells me that it exported. And if I go to the desktop, there's my transition. And as soon as Illustrator opens up, we can open that up. Now, when you export, there's another export that you can do. I don't know if you saw that. You can export this as an STL file. So we can export it as STL. And this is going to be a 3-dimensional part that you can print on a 3D printer. And I'm going to say very high resolution, and then click OK. And it exported it, and it's telling me that it exported it. And if I go back to my desktop, there's my STL file, and I should get a preview of that STL file here. It should. It's pretty big. There it is. So that is a 3D object that you can print on a 3D printer, but that's not the question that he asked. He wants to print it as a paper wrap. Okay, so to do that, again, you're in the transition editor. There's 3 things you got to do. One is you got to clear out the shoulders, because shoulders are not part of the wrap. So we do have shoulders. We just need this part here in the middle. So I'm going to go to the shoulders and then clear that one, because This is a wrap, so it makes sense. It's got to be hollow. And the third thing is the shape. We have to make sure it's conical because we can't print an ogive shape because it doesn't wrap. The only thing that wraps is a conical shape. So now that we have the conical shape, now we can export a template. And okay, so it's going to be SVG again, and let me put it on the desktop. And we've already got one called transition.svg, so let's call this one transition 2. And click OK to save it, and it saved it. And now we can go to Adobe Illustrator. Is it up yet? Still waking up. We got a question from F.A. Abdullah. He says, is RockSim free? And the answer is no. There's a free trial, but it's, if you want to use it past 30 days, you have to pay for it. The free trial, you can do everything that I'm doing here. You can export out all this stuff, so you can do that. Okay, so let's go to my desktop. Okay, so here's the transition number 1, and I'm going to open that in Illustrator because that's a vector program. And then I'm going to do the same thing as soon as it opens with transition number 2. Okay, so here's transition number 1, and you can see it looked just like that nose cone. So this was before we cleared out the shoulders on both ends, and we confirmed that it was hollow and that it was conical. So that's transition number 1. And now when we go back to the desktop and open up transition number 2, so here is a wrap. So we have this part, the gray part right here, when you print this out, will be the wrap that you can use to make your paper transition. And do we have a video on how to make that? I didn't want that, I wanted this. Let's go to, I'm looking for a video here on how to make transitions. And what you do, this is our video page, our archive, and once you're on this page, you can do a Control F for find, and let's type in transition. It's talked about 37 times on this page. A paper one. Okay, so here's one. Okay, so video number 143 would be a good one to watch. And also, that one you need to make a fixture, but let's see if I can on. Okay, so video number 10 through video number 13 is a sequence of how to make a transition. But it all starts with that paper wrap. You got to have this wrap. And if I were to print that out, then I could make my transition. So hopefully that answered your question. Sturk03. Carlos in Marietta, Georgia. Question 1. Do you have any information about the Quest B14-5T motor? Will there be different delays available? I am dreaming about staging. And the answer, I can tell you right now, there will be no B14-0. And that's what you want for staging. But you can't have a 0-second delay motor that's made out of composite propellant. There is no such animal. And the reason is it has to do with how composite propellants work. If you'd like to learn how to do that, so this is go to our how-to and guides page, come down here to rocketry, how-to and technical information. and then come over here to how composite rocket engines work. And this is kind of a video that shows how engines work. So this is like a cross section of a composite motor. So you have the propellant, which is this part here. This right here is the delay, and it's also the forward bulkhead. There is no, that delay has to hold the pressure in on the rocket motor. Because if that delay wasn't there, in a black powder motor on a 0-second delay, there is no delay there. But black powder burns from one end to the other end. This burns from the inside out. And if I click on it, so you got the igniter that goes in, and then it goes all the way up here, and you're gonna ignite the motor at the front end. And so the electricity goes in, it starts firing, and you can see it started burning along the inside. And it burns all the way from the top of the motor all the way back down to the bottom. And when it burns, it's going to burn from this side to here. But notice that this delay right here, as it burns, it's getting shorter because it has to hold that propellant in. See, it's getting shorter and shorter and shorter. And by this point, the propellant inside the motor has burned out, but this is still burning because it has to coast into the air. And then at some point it's going to get to the end, and when it does, there's black powder at the top that will fire off and push out the parachute. But in a black powder motor, that fire that comes out is what ignites the upper stage. Here we have a plastic cap that's in the way because that holds that black powder in, plus we have to have that delay. So you can't, the thing is, and I've tried this, is so you have all this pressure inside, and if you only have a thin sliver at the very front end trying to hold all that pressure in, it's just going to burst. So that is why we can't have booster motors that are made out of composite propellant. So the Aerotech B14, which is trying to mimic the old Estes B14, there's no 0-second delay. And that's unfortunate because that's what everybody wants, is a B14-0. It doesn't exist. It's not going to exist. It's just the laws of physics. The closest thing to a B14-0 would be if Estes would make a C5-0. And we have been lobbying Estes to do that because that would be the closest thing to a something that has a lot of thrust. The C5 has a lot of thrust, and it's a fairly short burn. So it'd be like the B14. It just has a little bit more power. It goes from a B to a C class. But very good question. Carlos in Marietta, Georgia says, question number 2. How would we make a delta fin with an Apple AirTag in it? It's a 32 millimeter disc, 11 grams. Imagine finding all the stages of a Comanche 3 using your iPhone. That's a pretty good idea. All right, so let's go back to RockSim. Let's finish this design. And actually, I should have left my shoulders on my transition, but let's go add that body tube, which is a BT80, which is a 66 millimeter. Okay, so now let's add some fins to this tube right here. So, and he wants to add an AirTag in it. So, how would I do it? I would probably make let's try with a fin first. So when you add a fin, it throws up a generic fin, And then it looks in the database. I'm going to say, no, we're going to take this generic fin, and we're going to try to put an air tag in it. All right, so it's going to be a 3-fin rocket. Let's make the material out of balsa wood. And let's make the color, I don't know, orangish, 3D color orangish. Okay, so there's our fin. Let's look at it in 3D. So right now, I don't know how thick an air tag is, but he says it's 11 grams. Let's go to Google and ask, how thick is an air tag? How thick is an air tag? And it is 0.31 inches and a bit thicker than a tile mate. Well, that tells me a lot. Air tags, here we go. 0.31 inches thick. Okay, so my fin, if I want this air tag in here, has to be 0.31 inches thick. So what I would do is I would make a fin, make it thick, 0.31. And when you do that, you can see my fin is a lot thicker now. And then I would probably cut a hole in it. So let me export out this template and let's cut a hole in it. So let's put it on the desktop. Let's call it the fin set. It's going to be an SVG, save. It exported it. And let's go here to this finder. And let's take this fin. Oops, I just want the fin. And I'm going to drag it into my drawing program. Okay, still waiting for it to open. Okay, so there's the fin. And then we're going to cut a hole in it. So I'm going to get my circle template here. And I think he used 0.32 inches. Well, that's a huge fin. So I'm looking at the size, and the diameter is 0.3. No, wait a minute. 32 millimeters. What's 32 millimeters? 1.25 inches. So that circle right there, I need to make it 1.25 inches. So I'm going to go to the transform. 1.25. 1.25. All right. So I would print this out, put it on my balsa wood, cut out the perimeter, and then cut out the circle in the middle, and then put my air tag in there. And then probably what I would do is I would just take some clear packing tape, one on each side of the fin, and that would hold it in. And then you could track your rockets. Although a Comanche 3, the fins aren't that thick. Don't save. So now to add the weight of this, so click OK here. And we're going to add the weight of the air tag. And I think I can't add a mass object, but I can add it to the body tube. And I can say mass object. And I'm going to say, here's the mass object, is that blue ball. And I'm going to say cancel out of that. And we'll call this an air tag. And let's look at it in 2D. So right now my air tag is right there, and I need to slide it into the middle of the fin. Ideally, I'd like to put it on one of the fins. However, I can't attach a mass object to a fin. I can only attach it to the tube, but it's in the right location for your center of gravity. It's going to make one fin heavier. If you are concerned about that, it might cause your rocket to kind of wobble as it goes up. So if you are concerned about it, I would probably put 31 grams on each fin. if that's what it weighs, or 11 grams on each, 11 grams. There we go, 11 grams. It's not a lot of weight, but it's going to slow your rocket down. David Hayes asks, does RockSim 11 flag new motors or updates when it does an automatic import so you can tell what has changed or is new? And the answer is no. Because that's what I was looking for too. Because it did the automatic updates. So if you wanted to force it to do an update, you go to the preferences, and then you go to auto engine update here, and then you can say update engine database right now. And right now I have mine set to only download certified motors. You will get a prompt if there's already a motor of the same name. I'm doing it once a month, and mine did it just a little while ago. Yeah, since it already did it a little while ago, it didn't find any new engines. But before I started this presentation, it did it, and there were new engines. So, but unfortunately, it doesn't tell you what new engines there are. If you want to see what engines are in your database, go up here to the File menu and go to Reload Engine Data. And this is the data. These are all the motors that are in your data folder. The ones here on the right are the ones that I want RockSim to use. So these are Aerotech. I don't want animal motors, so I'm going to remove those. So when it removes them, it puts them on this side. So this is kind of like a temporary holding cell for motors that I don't want it to show up in my list. Look, there's a whole bunch of animal motors works. If you don't want them, just hold down your shift key and select them. And then hit remove. And so they're gone. But it doesn't tell me which of these new motors came in. Yeah, oops, Gorilla motors, I don't need those. I think this is the one that we did last week, this H54, so I'm going to remove that one. Yeah, so I just cleaned up my database. The Cesaroni motors, I hate the naming this nomenclature comes from thrustcurve.org. When we used to create motor files, we would just give you the manufacturer name. Because this makes it really hard to find motors, because if you're loading a motor, I need to set this tube here as a motor mount tube. And when you go to load an engine, sometimes these names can be really funky. Let's see if I got any funky ones. So this is 54 millimeters. These don't look too bad so far, but sometimes they can sneak in. Especially on the bigger ones. These don't look too bad. Yeah, so I'm looking here at the engine code. All right, so the answer to that question, Sturk or David, was no, it doesn't flag them. So, and what I found out today, because this is like the first time mine has actually done it automatically without me asking, was that after it had downloaded the new engines, I did the same thing. I wanted to see if anything was new, and what it had done was took all my motors and moved them all over here onto this side. Because I know from last week when we were doing this that I had motors over on this side in the holding cell, and they got all shifted back over. So I had to move them all the way back again. Yeah. David Hayes says rats, that's too bad, but I can export new old motor lists and have a database of differences. Okay, so, but can I export a new or old motor list? Can you export a new? No, that's a good question. And the answer is I can't think of a way to do it from inside RockSim. Now you could go into your computer, into the Finder. See, if I went into this folder, this specific folder right here, so it's on my computer, it's in the users. Under Windows, the file path is different. I hope everybody understands file path because I don't want to explain it. So I got to go to users and see it's in a hidden folder. And I got to go to library. See, now I'm in my library folder. The library is a hidden folder. Then I got to go to application support. And then I got to go to Apogee components. Then I got to go to RockSim 11 data. Here's RockSim 11, and then the data. Okay, so now this is a list of all the motors that are in your data folder. However, as I said, sometimes there are just manufacturer. See, these are stored as individual motor files, but you can also store them as a group of motor files. And if I find, okay, so like this one right here, this Apogee, that's a group of motors. It's just not one motor file, it's like a whole bunch of them. And I can't, here's a list, and I could print out this list, I'm sure I could somehow, but I don't know what's inside of this grouping. I'm going to have to ask the programmer if there's a way to flag the new motors in the future version. That would be a good idea, because then people like me and you could figure it out. Hey, I got this new motor. What did it download? I don't know. That's a good question, David. And I had the same question. And this is how we add things to new versions, as we talk about what our frustrations are and how we can fix it. Okay, so I think that was the last question so far. So anybody else have a question? David says thank you. Yeah, no more questions. No more questions. What else can we do while we're waiting for a question to come in? Let me take a sip of water. Excuse me, went down the wrong pipe. I've never played with an Apple AirTag. Your AirTag still might detect not more than 100 feet deep inside of the pool. Okay. If you want to send me an AirTag to play with, that works. For free. Yeah, you can come to an Apogee website, and our address is right here. You can just send it to this address. I've never had an AirTag, so. Yeah, so we talked about how composite motors work. We have a similar one on how black powder works and how staging works, how to make your own rocket motor, how black powder motors work. Whoa, that's no good. I have to fix that. Let's see, we wanted to go to technical information. how two-stager motors work. Here's black powder is how rocket engines work. Similar little screen here that will take us through an animation. So that's a cutaway, and there's an Estes igniter going in. There's the plug going in, and the electricity fires it up. And see, it burns from the back end towards the front. These are called end burners. They burn from one end towards the other. Where the Aerotech was a core burner, it burned from the inside out. And when you go from one end to the other end, then you can do direct staging. But here's the delay. So now the delay is going to burn. It's also an end burner here, and then it's going to pop off that ejection charge right there. So this is a full-length version. Play it one more time. It's always interesting to watch these motors burn. All right. And then for the the black powder two-stage, go to again how two-stage rockets work. And we have this video. It took us a long time to create these videos. So again, you got two motors. These times they're stacked. And we're going to burn the first one just like we did before. It burns, but you saw there was no delay on this one. And so as soon as it gets to the end, all the hot gases now are going to go up into that one. And it ignites that one. And then what happens is once it ignites, this motor creates so much pressure that it pushes the stages apart. So that's what you're seeing there is a separation of the stages. And then it burns, and then its delay will burn. And then finally the ejection charge will go off, pushing the parachute outside of the tube. So that is how black powder works. And black powder, you can actually have the motors they don't even have to be touching each other. They can be separated, like in this case right here. So here's the booster stage motor, here's the upper stage motor. If you do separate them, you do have to put a little hole, a little vent hole on the side just below the nozzle of the upper stage so that any cold air that's above this engine gets pushed out first so that the hot air can get up into the nozzle. If you don't allow that cold air to get out, what's going to happen is that cold air is just going to compress. It's going to be pressurized. It's going to build up a lot of pressure, and it's just going to pop the top off without igniting it because it was cold air instead of the hot air. So this is also direct staging, but we call it gap staging. And you can, I've done, I think up to almost 18 inches, you can do direct staging or gap staging. Just make sure you have that air vent to let that cold air get out first. That's the trick. Alfred Indy says, David Hayes, are you planning on going to the launch on May 18th? Well, you better. Yeah, I think we have a launch on the 18th as well. That'll be next Saturday. We are getting close to the end, so I guess I could talk about that. My daughter is going to be coming home from college tomorrow, and I'm looking forward to that because the next weekend, I think she's available to fly rockets. I know she's going to a summer camp, but I thought that was, I hope it's not Saturday because I think we wanted to go out and fly rockets next Saturday before she goes off to camp. Because she's got a lot of rockets to fly. She's trying to try out for the FAI team. FAI is the international competition. So it's kind of like the Olympics where you got to try out to be on the team and then you can go compete against other countries. And she's done this a number of times before, but she wants to do it again. And so when she was home during spring break, we did do a couple of rockets. but we were building, so getting ready. So now she's only got like about a month and a half to get her qualification flights in before the tryouts. So I'm looking forward to that. It's always fun to fly with your kids. Okay. Alfred Indy says, if you practice flying using RockSim, you will be ahead of most people. I agree. That's the cool thing about RockSim. All right, so we've concluded another busy episode. We talked about a lot of things this episode, so we will archive it sometime next week, and it will be on our website, where I showed you the archive pages. That was episode number 166. And so next week we will be back again for episode 167. Same time, same station. Thank you for coming. So I'm going to give you a countdown, and then we're going to go launch. So in 5, 4, 3, 2, 1, go out and launch something.